Hello everyone, I'm Nitin Goyal, a third year engineering physics student at IIT Roorkee. Today I'll be presenting a short presentation on the topic medical image sensors. So first we would discuss about a few points about the medical imaging. So medical imaging is used in evaluating several illnesses through imaging. So it is critical in validating, analyzing, documenting the progression of a disease and their response to a treatment. The discovery of X-rays paved the way for advanced medical imaging technologies. Also, the MRI, X-ray, and the CT and the other imaging technologies have gradually evolved and been upgraded after years of research. There are also new imaging technologies coming up like the optical, infrared, ultrasonic imaging. Different imaging modalities like implement and use different kinds of sensors. So basically in this presentation we would be discussing more about the sensor part. So there are a lot of different technologies available for medical imaging, but here we will discuss mostly about the most modernized one, which is the camera based technology for medical imaging. So the camera-based technology is close to a no damage detection, which means whether it is a charge couple camera or like the CMOS camera, these have little effect on the human body during the detection process. The situation that may affect the human body is only the stress response for the human body to foreign objects. Like when the camera is being used to detect the inside of the human body, the person may face some stress response only. So the first sensor in the list is the CMOS sensor. The CMOS sensor or the complementary metal oxide semiconductor sensor, which is the full form of the CMOS, is one kind of electronic chip used to change the photons into electrons for digital processing. These sensors are mainly used for creating images within the digital cameras, digital CCTV cameras, also the digital video cameras. The low-cost manufacturing of the CMOS make it achievable to generate the low-cost consumer devices. The CMOS sensor works on the principle of the photoelectric effect, which change the photons into electrical energy. The CMOS sensor will change the electrical charge into voltage directly within the pixels. So here is the CMOS sensor design. As you can see on the screen, the every site include a photodiode on three transistor to perform different tasks like activating and resetting the pixel, amplification and charge conversion. Also, the multiplexing or selection of the charge from the photosensitive pixel at the pixel location can be changed to a voltage, and the signal is multiplexed through column. And the column is the signal is multiplexed through rows in the column, and it is received by the digital to analog converter. The CMOS sensor multiplexing configuration is frequently connected with the electronic rolling shutter. Like even though with extra transistors at the pixel location, a global shutter will be achieved where all the pixels are uncovered and the same time then read out serially. Also, the CMOS sensor multi-layer fabrication procedure does not allow to use micro lenses over the chip, which reduce the effective collection efficiency of the CMOS sensor. So basically the working is that the image sensor within the camera system receives the incident light that is focused on it through a lens. The CMOS sensor then converts the photon falling on it into electrons to a voltage and then after into a digital value through an on-chip ADC. Depending on the manufacturer of the digital camera, the component used in the camera system and its design obviously would be changed. Also, there are different types of the CMOS sensor. The first is the active pixel sensor. The second is the passive pixel sensor. The active pixel sensor is a type of image sensor which is designed with a collection of pixel sensors. In this type of sensor, every pixel sensor include an amplifier and a photodetector. Out of the different active pixel sensor available, the CMOS APS is the most famous sensor because of the great application it have. The CMOS sensor APS application, the application of the CMOS APS include motion capture cameras, X-ray imaging, endoscopy camera, and the digital radiography. The second one, the passive pixel sensor. Like in this sensor, every passive pixel include an access transistor and a photodiode. The pixel in this sensor are arranged in a two-dimensional structure through access enable wire shared through pixel within the similar row, and the output wire is shared through the column. Uh, Now, the second example of the image camera-based technology sensor is the CCD. The CCD was invented by Bell Labs in 1969, and after years of development, it has been widely used in the medical imaging, astronomy, industrial detection, and other fields. A CCD, a charge coupled device, which is a full form of CCD, is an integrated circuit containing an array of linked or coupled capacitor. Like under the control of an external circuit, each capacitor can transfer the electric charge to its neighboring capacitor. So basically we can say that an image sensor which make use of the principle to shift and read out the charges of the light active pixel is called as the CCD sensor. Design of the CCD sensor is like this. The photoactive region of a CCD is generally an epitaxial layer of silicon. It is lightly p-doped and grown upon a substrate material of a p++ material. This region defines the channel in which the photo-generated charge packet will travel. Also, the gate oxide, which is the capacitor dielectric, is grown on the top of the epitaxial layer and the substrate. Later in the process, the polysilicon silicon gates are deposited by chemical vapor decomposition. Also, the pattern with photolithography, and it's in such a way that the separated phase gate lie perpendicular to the channels. Also, the channels are further defined by utilization of the low-cost process to produce the channel stop regions. The channel stop are thermally grown oxide that serve to isolate the charge packet in one column from those to another. So now the CCD working, like how the CCD sensor is working, we can say that an image is projected through a lens onto the capacitor array as discussed, the photoactive region part, causing each capacitor to accumulate some charge, electric charge proportional to the light intensity at that location. Also, an one-dimensional array is used in line scan camera, capture a single slice of an image. Once the array has been exposed to the image, a control circuit causes each capacitor to transfer its contents to the neighbor, operating as a shift register. The last capacitor in the array dumps its charge into a charge amplifier, which converts the charge into a voltage. By repeating this process, the controlling circuit converts the entire contents of the array in a semiconductor to a sequences of voltage. So this is the basic diagram, like how things are working here. Like as you can see, the charge package electrons, which are in the blue color, collected in potential wells, which are in the yellow color, like created by applying positive voltage at the gate electrodes. As you can see, there are gate electrodes there, and the voltages are being applied there. Like applying positive voltage to a gate electrode in the correct sequence transfer the charge packets as it is required. So basically that was the two sensors. So now I would like to discuss the conclusion part of the presentation. So in the future, the development of medical image sensor will generally like move in three directions. The first direction is the miniaturization direction. Like with the further development of microelectronic processing technology, especially the nano processing technology, sensor technology will move from the microsensor to the nano sensor. The second direction is the intelligence. The intelligent sensor is a combination of one or more sensitive components. And the third direction is the networkization and the socialization, by uploading the collected data to a network and comparing it with the previous results. Like data can be returned to the device to realize the socialization of big data in the medical imaging. Yeah, that's it. I hope you liked the video. Uh, have a nice day, everyone, and thank you very much.